This is day 4 of our unit on function composition and inverses. We're going to be talking more about inverses today. Specifically, we are going to be graphing the inverse of a graph that we're given. We will also be finding the equation of the inverse given an equation. And lastly, we will be using composition to verify that two functions are inverses of each other. All right, let's start with the graphing. Remember that finding the inverse of a relation has to do with switching the domain and the range, switching all the x values and all the y values. So if you're dealing with a graph, here, let me get a better color. If you're dealing with a graph, the easiest thing to do is look for points where the grid lines meet exactly. So like this point, and this point would be good points with which to start. Now ask yourself, what are the x values and the y values? Now look, guys, this point has the coordinates, let's see, as I scan over this curve, I'm actually seeing several points where the function hits the grid lines perfectly. And I'm actually seeing 7 of them. Okay, so see if you can find all 7 points where the graph crosses perfectly where the grid lines meet. So this one is the point -9, 3, and this one is -4, 2, and this one is -1, 1, and of course there's 0, 0 in there. But this one is 1, -1. And then this one is 4, -2, and this one is 9, -3. So those are the ordered pairs for each of these 7 points. So if I want to graph the inverses of each one of these, I need to reverse the x and y. So I think I'll graph the inverse in blue. So looking at this first point, -9, 3, the inverse of that point would be the point 3, -9. Let's see where that is. So 3, -9 would be right here. Let's look at the next one. Let's clean this up as we go. All right, looking at -4, 2. The inverse of that would be 2, -4. Okay, so 2, -4 would be right here. All right, the next one is -1, 1. The inverse of that would be 1, -1. Okay, so 1, -1 would be right here. All right, the next one is 0, 0. So the inverse of 0, 0 is still 0, 0. So that'll be like that. All right, then we have 1, -1. The inverse of that would be -1, 1. -1, 1 would be right here. Now, this point is 4, -2. The inverse of that would be -2, 4. -2, 4 is right here. All right, and the last one, 9, -3. The inverse of that would be -3, 9. And negative 3 comma 9 would be right here. Okay, so these blue dots give us a pretty good impression of what the inverse is going to look like. We should just go ahead and smoothly connect these dots to show the wave of the inverse function. So the inverse function should look something like this graph shown in blue. Looking at example 2, I see 5 values that I can really use to help me find the inverse of this graph. All I need are these ordered pairs. So this is the point negative 6 comma 3, and this is negative 3 comma 1, 0 comma 3, this is 3 comma 5, and this is 6 comma 3. Now, if I want to graph the inverse, I can just graph the inverse of each one of these 5 points and connect those dots. So this, instead of negative 6, 3, it'll be 3 comma negative 6. Instead of negative 3, 1, it will be 1, negative 3. Instead of 0, 3, it'll be 3, 0. Instead of 3, 5, it'll be 5, 3. And instead of 6, 3, it'll be 3 comma 6. So if I graph all these inverses, I should be looking at the inverse graph. So let's go. 3 comma negative 6 would be like right here. Okay, so that's my 3 comma negative 6. All right, 1 comma negative 3 would be right here. 3 comma 0 would be here. 5 comma 3, here's 5 comma 3. And finally 3 comma 6. Okay, that's going to be in the way. Okay, so I'm graphing 3 comma 6 would be right here. All right, now looking at those blue dots. Oh yeah, you know what, I should have mentioned this before. Looking back at problem number 1 for a moment, one other thing about functions and their inverses. If you graph the inverse of a function, what you should be looking at is the reflection of the original graph over this line, the line y equals x, this diagonal line. Okay? So looking at that diagonal line, let's make it a little bit darker, and let's make it green. All right, this green line is the line y equals x. And this should be the mirror line, the reflection line. If you graph the original function and its inverse, this diagonal line should split that double image right down the middle. There should be balance diagonally across this. So keeping that in mind will help guide you as you connect those dots. So in this case, as I'm connecting these dots, and you know, I might try to be neat with this and use actual computer lines if I can. So it would be like this, and like this, and like this. Okay? All right. So this is what the inverse function should be looking like. And once again, notice that if I take this diagonal line, y equals x, this diagonal line, y equals x, splits the double image right down the middle. There's perfect balance on either side. And that verifies for me that I've correctly graphed the inverse. Okay? Now, let's look at finding the inverse when I give you a table. Well, that's so easy, it's pretty trivial. All you have to do is reverse the x's and y's. So the inverse of this would be 3, negative 2, 7, comma 5, and negative 1, comma 4. Okay, not that much to it. Okay, so on number 4, it's going to be the same thing. We just switch the x's and y's. So it'll just be in table form. So the inverse will be 0, 1, 3, negative 2, negative 2, 4, 2, 2, and negative 1, negative 2. Okay, just switch all the x's and y's. That's all there is to it. All right, now, number 5.
Yeah, it's hard for me.
True. Peace. All right, looking at number 5. If we want to find the inverse of a function, you just switch the x's and y's and solve for y. So this will be x equals negative 2y plus 5. We will subtract 5 from both sides. So that will be x minus 5 equals negative 2y. Then we will divide everything by negative 2. Like and So those are going to cancel each other out. And now we have, I'm going to go ahead and write the final answer. So x over negative 2, this is the same thing as negative 1/2 x. If you wrote x over negative 2, that would be fine. Don't forget, a negative divided by a negative is a positive. So you should have plus 5 over 2. So this would be your final answer for number 5. Any question on that? Okay. Looking at number 6. So again, just switch x and y and solve for y. So this is going to be x equals 3y minus 3. So just add 3 to both sides. So this will be x plus 3 is equal to 3y. And just divide everything by 3. Here, here, and here. So these cancel out. So the inverse will be y equals 1/3 x plus 1. You could leave it as x over 3 if you wanted to. Any questions on that one? Okay. All right, look at number 7. Switching the x and y's, we're going to have x equals negative 12y plus 7. Subtract 7 from both sides, so that's going to give me x minus 7 is equal to negative 12y. Go ahead and divide both sides by negative 12. So those are going to cancel out. So that's going to give me y equals negative 1/12 x plus 7 over 12. All right, so that'd be number 7. Any questions right there?
Yeah.
All right, good man. Now, number 8, all fractions. Watch out. We'll try to remember what we talked about. So this is going to be x equals 1/2 y plus 6. So what did we say that we would do when we have a fraction involved?
Multiply the denominator.
Multiply by the denominator. Okay? So we're going to multiply everything by 2. Don't forget the 6. Don't leave that out. So we're going to multiply by 2 in all 3 places. All right? Now these 2's are going to cancel each other out. So we will have 2x equals y plus 12. Then just subtract 12 from both sides and you're done. So the final answer will be y equals 2x minus 12. All right, any questions on that one? All right, look at number 9. Okay. So again, this is like having x equals y squared minus 1. So we're going to need to add 1 to both sides. So that'll just be x plus 1 is equal to y squared. Now, somebody tell me what I'm going to do next.
You have to square root.
You have to square root now, okay? To unsquare that y, we're going to take the square root of both sides of the equation. So I'll take the square root over here, and I'll take the square root over here. Okay? So that's going to give me, bye, sweetie. See you tomorrow. That's going to give me y is equal to x plus 1.
Well, what do you know? I was doing it the same time you were.
All right. Now, for my experts in the internet out there, technically this is a plus or minus, but I don't want to confuse my kids today. We'll talk about that tomorrow. Okay? So for now, we're just going to leave it like this. Any questions on number 9?
Nope.
All right. Number 10, finding the inverse. This is going to be x equals y squared plus 3. We need to subtract 3 from both sides. This will be x minus 3 is equal to y squared. And just like before, we're going to take the square root of both sides. Okay? Again, technically this should be plus or minus, but we'll worry about that tomorrow. So this is going to be y equals the square root of x minus 3. Any questions on that one? All right. Look at number 11. So we'll start off by switching the x and y. So this will be x equals y plus 8 over 3. So Nike, tell me what I'm going to do next.
You're going to multiply both sides by 3.
Yes, sir. We're going to multiply both sides by 3, like so. That way these are going to cancel each other out. So now we've got 3x equals y plus 8. All right, Devon, what's the last step?
You gotta subtract 8.
Yeah, we're going to subtract 8 from both sides. So that will give us 3x minus 8 equals y. That's basically the answer. I like to write it facing this way, but that's basically the answer. Y equals 3x minus 8. Questions?
I understand it now.
All right, good man. All right. And once again, switch the x and the y. So we're going to have x equals y minus 1 over 4. All right, Noah, tell me what to do.
You have to multiply 4
Okay.
on each side.
Yes, sir. So those are going to cancel each other out. So I'll have 4x is equal to y minus 1.
Got it.
Now what?
You have to add 1.
Absolutely.
That's just gonna be 4x plus 1 equals y.
Correct.
I'm gonna ace this quiz tomorrow.
That's what I want to hear.
I'm going to be honest.
Wait, there's a back, bro. Oh.
Yeah.
Yours doesn't have a back?
No, this one though.
All right, you got a bootleg version.
Darn it. I should have got that one. Yeah.
All right, for these problems, we're supposed to use composition to verify that f and g are inverse functions. So remember, if we want to show that two functions are inverses, we have to do composite 2 ways. So on the one side, we're going to do f at g. Okay? And on the other side, we're going to do g at f. Now, who remembers what I'm supposed to get if they are indeed inverses?
X.
X. Okay? If I do F composite G, I should get X if they're inverses. If I do G of F, if they're inverses, I'm going to simply get X. Yes?
How did you figure out this part, to put F and G? That's what I don't understand.
You just memorize that. That's just the procedure. You always do one function into the other.
Okay.
If you've got two functions, you always do F with G inside, and then you do G with F inside.
Okay.
Just every single time. Okay, so let's start with doing F at G. Alright, people from the internet. If you don't know how to do composite functions in general, you need to look back at previous videos. Like this is day 4. So I think if you look back at day 1 and day 2, that's when we really talked about doing composite functions. So if you have not watched the day 1 and day 2 video, you should pause now and go back and watch that before you watch this.
Wait.
So the way composites work, if I want to do F of G, start with F. It says 4x plus 32. So you should start off, just write the function, but instead of x, put parentheses. Alright, so instead of having 4x plus 32, start off with 4 parentheses plus 32. Now, Haley, what am I going to put in the parentheses?
X over 4 minus 8.
Sure, I'm going to put the other function, that x over 4 minus 8. Okay, that's the G. Now, it's a matter of simplifying this stuff and hoping that we get x as we should. Alright, who can tell me what's going to happen next?
You're gonna do distributive property.
I'm going to do the distributive property. Alright, I'm going to do the 4 here, and I'm going to do the 4 here. Now, when I do 4 times x over 4, those 4's are going to cancel each other out.
Because 1.
Exactly. Like basically when I do these, those 4's will cancel. So that's just going to give me x. Now when I do 4 times negative 8,
You get negative 32.
you get negative 32.
And then it's just x.
Okay?
Oh, okay.
Now make sure you show this step. So when I look at your work, I should see the original setup, and then I should see x minus 32 plus 32. And then you can cross those out, and yes, we get x. So we're halfway to proving that these are inverses. Did I lose anybody?
No.
Okay. Now, going the other way. So this time I'm starting with function g. So instead of x over 4 minus 8, it would be like having parentheses over 4 minus 8. Alright, so inside the parentheses should go the other function, function f. So I'm going to have 4x plus 32 in there. In this case, the parentheses aren't really doing anything. There's nothing in front of the parentheses, or there's no exponent or anything. So dividing by 4, all you're really doing is you're dividing each of these terms by 4. So the first term, those 4's cancel out, and you just get x. And if you do 32 divided by 4, you get 8. And then you just bring down this minus 8. And of course, the positive 8 and negative 8 cancel each other out, and once again you get x. So that is how you prove that these two functions are inverses, because you got x both ways. Alright, so bye-bye, sweetie. So that was number 13. Let's move on down to number 14. So again, if I want to show that these are inverses of each other, I have to do two things. I have to do f of g, and that better give me x, and then I have to do g of f, and that should give me x as well. So f of g, so that should be starting with function f, negative 3 parentheses plus 6. And then on the inside, I put function g. So negative 1/3 x plus 2. So 3. If I do the distributive property, Negative 3 times negative 1/3 is 1. So really that's just x. Negative 3 times 2 is negative 6. And then I just bring down that positive 6. And those will cancel each other out. And once again, we have x. Okay, do not skip that step. And we have to do the same thing the other way, g of f. So if I start with function g, I'm starting with negative 1/3. Instead of x, I'll put a big old parentheses plus 2. Okay, so that's function g. Inside the parentheses, I put function f, because that's what's inside. So negative 3x plus 6. When I do my distributive property, negative 1/3 times negative 3 is 1. So that's just x. Now, Noah, what's negative 1/3 times 6?
It's negative 2.
It's negative 2. Okay? And then I just bring down the blue 2. And those cancel each other out. And once again, I get x. So since I got x both ways, that proves that these are inverses. Okay? I think there's one more. Alright, number 15. Once again, if I want to show that two functions are inverses, I have to show that f of g gives me x, and I have to show that g of f gives me x. So let's start with function f. 4x plus 1 becomes 4 parentheses plus 1. Inside the parentheses, I will put my 1/4 x minus 1/4. Alright, it's time to do the distributive property. Noah, do you know what I'll get if I do 4 times 1/4?
Yeah, you get 1x.
You get 1x, okay? And I'll just put x. And what do I get if I do 4 times negative 1/4?
Negative 1.
Negative 1. And then I'll just bring down the positive 1. Okay? Obviously, what's going to happen now?
Those two will just cancel out.
Those two will just cancel out. So far so good. I get x. Alright, now let's do the g. So I have 1/4 x minus 1/4. So that's 1/4 parentheses minus 1/4. So inside goes function f, which is over here. So inside goes 4x plus 1. One more time with the distributive property. What will I get when I do 1/4 times 4x?
X.
X. Now, what's 1/4 times 1?
1/4.
1/4. So I'll have x plus 1/4. Now I'll bring down the blue. Minus 1/4. Now what happens?
It will cancel out.
Yeah, the positive 1/4 and the negative 1/4 just cancel out. So that'll just be x. And that proves that they're inverses. Okay? Was that it?
Yeah.
Alright, as the end of this lesson, I hope it was helpful. If so, a like is always appreciated. Give me that thumbs up. And I will see you on the next video.